Howdy, Professor Parks, PhD, and I welcome you back to the channel for another installment of my Conversations with Flat Earth. Sometime in late May, early June, I had the opportunity to speak on Troubling Tribune's podcast, and I will link the YouTube description below. Now, the conversation was primarily between Troubling Tribune and Jim Waterworld, another outspoken member of the Flat Earth community. There was also another gentleman there, but I honestly don't quite remember who they were because they didn't really speak up so much. Again, the conversation was primarily between Tribune and Jim and I, or me. And as with other conversations with Flat Earthers that I've had, or to be fair, Tribune describes himself as a true earther. Not to put words in his mouth, I believe he does describe his position in the video, but from my understanding, he is a globe skeptic. He makes no affirmative claim as to what the shape of the Earth is. Really, only his assertion seems to be that the Earth is in fact the center of the universe. But I'll let you watch the entire conversation and come to your own conclusions about what he may or may not believe. My goal is to try to understand why he holds those beliefs and why Jim holds the beliefs that he does, because they fly in the face of accepted science, of what we know to be the most accurate description of the universe around us. Now, I won't say that I got really an answer about that from either Jim or Tribune. They did provide me with clues as to what it is, and Tribune did go a bit at length about indoctrination, although that may be my word, not his. But he does believe that there is interference in the American educational system by the Rothschilds and the Rockefellers and some others. But he was he was not very specific as to who these people were, what their motives were, or really even if there was, in fact, a shadowy they behind all things. But again, I want you all to view this and give me your thoughts as to your thoughts on his answers. Both, do you agree with him? Do you not agree with him? If you are part of the globe skeptic community, as I guess it's now being called, please let me know what you think. This is a two-part series, and the last thing I will say before I stop rambling on and allow you to view the interview or the podcast is that I will freely admit that I am, as you've probably already guessed, rather long-winded. And my conversation with Flat Earthers definitely have gone for hours at a time, as you can see from previous examples on my channel. This conversation only went about 2 hours, and the reason for that was because I was getting frustrated. I was getting frustrated by certain words that were being used to describe modern science. I felt not quite disrespected, but I was just simply getting frustrated with the conversation. And then Austin Whitsitt showed up, who if you can see on the channel, I've had a long conversation with him. And not only did he show up, but there were a number of other globe skeptics as well. And I will, again, be honest and say that I ducked out primarily because I did not want to get into a long, drawn-out conversation with half a dozen or so vocal flat earthers, globe skeptics, when I was that frustrated. I didn't think that I would present myself well. I don't believe that I would present my arguments very well. And so I felt it was best for me to step away and allow them to have their space to talk about whatever it is they talked about. Okay, well, with all that being said, thank you for being here. Thank you for watching. And again, be sure to check out part 2 if you like part 1. And as always, like, share, and subscribe. I post content about astronomy and mental health awareness. So, peace out and clear skies.
In the waiting room already. Nice, dude. Let's get it going. Got Rob Parks, Mr. Jim. Appreciate you, Waterworld. we got Brenda in the chat. All right, before we bring them on, let's go ahead and talk about the topic of the title of today's show, right? The ability for the audience veto. I get a ton of mixed opinions when it comes to my guests, right? And honestly, more or less, I really don't care what people think about people's private lives. I care more about the arguments and things being presented when it comes to this channel. So I really don't mind occasionally having somebody like Brenda on to make some points, and then of course to remind us what it's like to regurgitate old nonsense from time to time. So for me, I could have it either way. I don't really like to limit people's free speech, but I also have a lot of people that were complaining. So what I have done, just for fair value to the audience, right? Because it's actually not just about me; it's about you all as well. So there will be the ability for any of the guests to audience veto, right? But it is pretty difficult. In order for an audience veto to go through, you're gonna need at least what is it? At least over half of the audience to veto them out. So, with that being said, we will go ahead and admit Brenda. All right. Welcome to the show. All right, let me get this. I don't know how to close this out. Perfect. All right, everybody's muted. Can you guys hear me all right?
Yep. Can you hear me?
Awesome. Rob, thanks for coming on, man. I appreciate it.
No problem.
Jim, welcome to the show. Brenda, welcome to the show. Audience, welcome. Let's get things rocking and rolling, shall we?
So essentially, I am the guinea pig for being voted off the island.
No, it was
nobody would ever do that, Professor Parks.
No, if anybody's at risk of being voted off the island, it would be Brenda. I've received the most complaints. No offense, but that's why I do leave it up to the audience in that scenario. If over half of them want any of my guests gone, and Jim, I mean, let's just be honest. If we get a lot of, if we start getting popular and we get a bunch of Globers in here, they could very easily vote you off the island too. So it's actually a two-way street.
Oh no!
It's the best way to keep it as fair as I can while respecting everybody's ability to speak. But if this show started to tank with just me talking, I probably would hang it up. Right? The audience does ultimately decide.
You mean like yesterday?
What happened
yesterday?
We had 0 viewers, practically.
Who did?
You.
Already off with it. That's super funny.
Well, I was going to start off by congratulating you on getting 1,000 subs. I've been at this for, I guess, probably 2 years at this point, and I only got 400.
Oh, nice.
So, not that I'm complaining. I love my audience, but I do appreciate the hard work you've put into this channel. So, congrats on that.
Yeah, I definitely
Absolutely.
I think we get a modest amount, but the Tribune show has always been the one to struggle, right? It doesn't have quite the allure of the True Earth debates, which are definitely the most popular. But what can you do, right? It is what it is, and I just like doing the show.
I think if you want to gain in popularity, you would have you would be the moderator of debates, and you would essentially do modern day debates one step better than they do. That would be my guess as to your best path towards gaining viewers.
It's actually true, Brenda. I actually agree with you on that, because when you're taking the fence and you're not really picking a side, it leaves room for everybody on all sides of the aisle to join up. But I also didn't want to hide my public opinion or my personal opinion about it, because that would just make me feel wrong. So I do tend to moderate and try to keep it very fair. But we all do have our biases. It's true.
I think you're a halfway decent mod. You should. Other than that, another way to grow your audience might be to moderate for modern day debates as a way of driving people to your channel. That might be one way to do it.
Certainly would improve modern day debates.
It's not hard to do that. Yeah,
You just reach out.
Precisely.
it's pretty low level. Seems to be. I don't know why that is.
Yeah.
I'm not sure of the dynamics going on there. Right.
I found James is all right, but his other two assistants or colleagues, they really don't know how to moderate at all.
Well, James has. My understanding is that James has a particular belief about moderating, which is basically not moderating.
to just not just let him in the cage, provide the platform, and just
Yeah,
take a
yeah,
step back.
yeah.
Then his
Yeah.
colleagues are just taking that philosophy and running with it because they basically do nothing.
I've been guilty of that a
There,
few
there.
times. I can't lie. I've had Jim just completely bulldoze over some guests in my TikTok, and
So you could expand this. I would be happy, and I'm sure there's others that I'd be happy to debate politics or religion also.
oh, it's definitely coming. We're already debating religion with the True Fate debate. We are going to be doing that Wednesday. Thanks for the opportunity to shamelessly plug that. So we are
True
doing
what?
True
what?
Fate, like the fate. What is
True
the fate of?
fate.
Yeah, what is the fate of humanity? Right. That's often
Oh,
what
okay.
ties in with religion. So
I heard true faith, but
Yeah, well, that's pretty easy. In about 5 billion years, we're going to be burnt to a crisp when the sun expands, goes into its red giant phase.
you
Oh,
actually
no.
you agree with some versions of Christians that think that God's going to end the world by blowing up the sun, or either
Okay.
that or by bringing the
Well,
world up to the sun. There's multiple different interpretations. I think they're all kind of woo. But in any case, that is a debate for a different time. We are here to talk about the shape of the Earth, our place in the cosmos. Luckily for us, we do have the privilege of having the chance to discuss this with somebody with a little bit of experience, some expertise. Rob, why don't you go ahead and introduce yourself, your background, and why we are so lucky to get to talk to you today.
I don't know about lucky, but my background is I have a PhD in astronomy from Georgia State University. I received it in 2014. Roughly speaking, my scientific interests are in young stellar objects or protostars, as it were, basically forming stars, forming planetary systems. I also am interested in magnetic fields, stellar magnetic fields, and I've used a rather innovative technology or innovative technique called interferometry in order to investigate that. And I actually got my master's back in 2000, so I've been an educator and in astronomy for past couple decades at this point. So, and my interest right now is in public outreach and science communication on top of my teaching duties. So that's basically me in a nutshell.
Very cool. And then you got two Joe Blows from Kokomo. We got myself, of course. I'm just some random guy on the internet talking some things that I think are interesting. And then we have Waterworld. Jim, go ahead and I'll let you introduce yourself to the panel.
I am first of all, thank you, Mr. Professor Parks, for being here. Thank you. Hey, I am as of November 2021, I gave up my 60-year indoctrination of the spinning space ball in the vacuum of outer space and found out November 2021 that we no longer inhabit a ever expanding universe. I didn't know that for a little while after that. And so I decided to look into general and special relativity the first of the year, got a pretty decent understanding of it. Now I'm looking into quantum mechanics. And Professor Parks, I have a lot of questions for you tonight. Hope we can I know we'll have a nice exchange because you're a nice guy. Hopefully I'll be a nice guy and we'll go from there.
All right.
I'm sorry, I'm checking the chat here. They just told me to turn myself up a little bit. I just turned my gain up, guys. If you're still hearing me pretty low, just let me know and I'll see what else I can do about it. Maybe I just need to speak up a bit, but I do have some sleeping kids in the house, so pardon me. It's just a natural urge to be quiet. But in any case, real quick, if somebody in the chat could inform me on how I can even start Q&As and votes and things like that, because I just realized I actually don't know how to do that.
There's got to be a vote. I know there's a vote in or polling in YouTube itself, but I don't know how to do it.
My
Well,
goodness.
your volume on Zoom here is decent,
Oh yeah,
so there's no problem here.
The problem is
Uh,
that everything goes through the mic, and then the mic goes to OBS. So it's some way that the mic internally mixes it.
uh-huh.
yeah. OBS is opaque when it comes to the audio mixing. I've had similar problems with it.
By the way, I am. My name is Brenda Van Ozen. I am 66. I am on Social Security. I'm retired, all that stuff, and I have time on my hands. I like debating philosophy. I've been debating with other people interested in philosophy for years, and then I sort of got interested in flat Earth and creationism and apologetics as a way of. I take a very different approach from a lot of the what I see as flat Earth debunkers is a lot of them seem to be retired engineers or people with degrees, and they take a very strong evidentialist approach, and I take a more conceptual approach, which is I analyze the claims made logically and find them deeply wanting. And I think that part of the problem that people react to me, one, it is an extremely conservative religion, bordering on a cult, and they're extremely biased against trans people. And they also react rather strongly when conceptually you disprove them, rather because you can argue evidence all the way to the cows come home, but you can't argue a logical refutation, for instance, of the one that I like in particular is what's called the black swan argument. It's logically fallacious. It must be abandoned. Otherwise, you're simply promoting a false argument.
Excellent. I didn't know that, Brenda. I've seen
Yeah,
you
yeah.
around, but I
Yeah.
didn't actually know your background.
I get around because, again, I have time. I don't have anything. I do other things. Actually, I've been doing plenty of other things today. But I was on with Jeranism a couple days ago and humiliated him. Just humiliated him. He doesn't think so. None of them do.
Well,
And same with Witsit. I humiliated him, and they all think that they win because they think that yelling and muting and kicking somebody is how you win an argument, and it's not.
Everybody thinks they win, don't they?
Yes, but only some people actually win.
That's true. That is very true. That's very accurate.
I avoid winning by not debating.
Oh man, you done
but,
messed up stepping into this platform. Then this is
Well,
I just want to real quick, Brenda. I know this is kind of off topic of the true earth, but what philosophical stance do you think is most true, or is most?
I'm a methodological naturalist and physicalist.
Okay.
Yeah.
My understanding of philosophy is limited, but I have spent the most time with the existentialists. So.
Oh yeah, that's it. I like existentialism. It's pretty good.
Except for Sartre. I think Sartre's up his own ass, but
I like Nietzsche.
No, yeah, Nietzsche. I really appreciate Nietzsche. I actually find his misogyny to be somewhat hilarious, because it comes out of nowhere in his books. It's just I find anyway. Not to derail the conversation, but
it's completely derailed. Everybody's very bored.
I'd like to ask Professor Parks. I never have, even though we talked on a couple occasions, not too long. Could he walk us through when somebody takes a photo, either from a laboratory or on Earth terrestrially, or even the James Webb or the Hubble, which I know is not in outer space? How does that whole process go through until we actually see it on social media or online or whatever? And what part do you play in that, Professor Parks?
That's a really good question. I'd like to know.
it's all right. So there was a couple things in there that seem to be. So you have Hubble, you have James Webb, and you have essentially any space telescope is going to run through the. Oh, did Brenda get kicked off the island already?
Yeah, sorry about that. It's out of my hands. Over 50% voted.
Oh, okay.
Sorry,
Well, that sucks.
it's
So
You're not
come on,
ma-
give her a little bit more chance.
it's the rules of the island.
Okay. Okay.
I can't do anything about it. They can vote. They can vote to bring somebody back on too. How about that? If they think that was too mean or too harsh, you could redo it, I suppose. But
because we didn't actually hear any of obviously we heard her talk about other debates, but we didn't actually hear her point of view. But anyway, Jim, to get to your question, so there are sort of two avenues of this, and so what I'm thinking of is with Hubble and JWST. These images are requested by what we call principal investigators or astronomers who are leading a research group. And is this Ruhif?
yes, sir.
Who are leading a research group. And they basically tell the space telescopes what to observe, when to observe it, for how long to observe it. They do so. The Space Telescope Institute collects that data and then gives it over to the research group. Now, how the pretty pictures become public, I'm honestly not sure. I'm assuming that there is some kind of sharing deal in progress or in place where Space Telescope or NASA has the rights to take the images that have been requested and create pretty pictures and put them out for promotional material. Now, from a research standpoint, what I can tell you is any astronomer who takes data, either from a space telescope or remotely from a ground-based telescope or at a ground-based telescope themselves, they will download that data. And then they will also download calibration frames, which take care of certain electronic artifacts that are in the digital image, the raw science image. They will calibrate that image in a way that is systemized across all of astronomy. All astronomers essentially do this. They all agree that this is how these images should be calibrated to get rid of instrumental noise, dark current, things of that nature. And then it is essentially up to the investigator what they want to do with their data. Now, typically, almost all in astronomy, the only way you're going to see their end product, their data, is when they publish the paper or they put out a press release through NASA. Now, NASA press releases, I don't know if NASA itself uses them, but I do know that astronomers who are not affiliated with NASA will say, hey, we just discovered this really cool thing. Can you please advertise it to the world? And NASA will do so if they agree that it is an interesting thing to do. I have never done that myself. I have never been a part of a press release, although in hindsight, I probably should have, but that's another story entirely. So the only way you're going to see their data is if you look at a press release of some sort or their final paper. For myself, I've got pretty pictures that I've made, well, at least attempts at pretty pictures that I've made that I have put on websites that if I can get my ass in gear, I will actually do live streams putting these things together. So that's the long and short of it. I don't know if that answers your question or not.
Yeah, I have so many questions. Thanks for coming on. I've been wanting to talk to you for quite a while.
Yeah.
So you have a ground-based terrestrial telescope yourself?
George Mason does, that I am the deputy director of. I should have mentioned.
Is it land-based or is there some elevation to it on a hill or a mountain?
So it has elevation. We are here in Fairfax, Virginia, which I think we're about 300 feet, about 100 meters above sea level. And then the telescope itself is on a tower that is 4 stories high. So it is above the ground. So I think if you want the absolute, I think we're about 130 meters off sea level, but that's a very rough estimate.
Does anybody that you know of that you're, aligned with or know, take a photo, through a telescope terrestrially and go all the way through the process to publish it themselves? Or is there a chain of command that is broken all the way through, that people are basically have assumptions that they're going to continue on the process until NASA shows an image, to the world? I get this opinion. Nobody terrestrially looks up at the sky and sees a galaxy or a nebula or anything like that, sees it terrestrially through the telescope, removes their eyes, puts a video camera there, because we are in the year 2023, puts a video camera there and records what their eye just saw. I don't get that whatsoever. That is not happening. Is that correct?
Okay, so for the vast majority of images that are taken, and you can Google, they have nothing to do with NASA.
Are we just going to ignore this Apollo 11 director?
This is historic. Don't worry. I can wait.
Oh, the ZWO series. I am. That is on my list. Getting a planetary camera from ZWO is definitely on my to-do list or wish list. But I think to answer the first part of your question, if you have a PI, principal investigator, they're going to take the images. They're going to then process, or their group is then going to process the images. And they're going to analyze those images, and they are going to release them to the public, usually through papers, usually through a published paper. NASA, unless that data was taken through a space telescope, NASA isn't a part of this equation at all. The only way that NASA could be even associated with this is if the grant to take these images, the grant money that was given to fund this project, that money may have come from NASA, but the oversight of that budget actually belongs to the university or the research institution. NASA is simply giving money. They have no say whatsoever on what the money, how the money gets spent once it leaves their hands. There are guidelines based on the institutions, the universities, and research institutions on how that money is then divvied up and is allowed to be spent by the principal investigator. There are, in terms of looking at what you would see, well, there is the thing that you have to keep in mind is when you look through an eyepiece through a telescope, you are getting to a certain extent the advantage of the size of the telescope, which allows you to see fainter in the sky than you could with your normal eyes. So you can visibly, depending on the sky, you can visibly see things like the Andromeda Galaxy, the Orion Nebula, the Whirlpool Galaxy, things of that nature with your eye. They're honestly not going to be spectacular images. They're certainly not going to be compared to what you could find by Googling them. But once you put the camera on, you can do something human eye can't. And what that's called is you can lengthen the integration time. So basically, your eye, your retina is a detector, and it will stay open. It will detect for a very minute amount of time. I think it's microseconds. And then it will take that data that is collected, that light, it will then send it to your brain to be processed. For a camera, you can open up the shutter and take a long time-lapse exposure for seconds, minutes, even hours. That is going to give you a much greater deal of light. That is going to allow you to see much fainter and with finer detail. So depending on the camera, the telescope, the system, you can, like I said, you can take exposures and then add them up later, and you can look at an object for effectively as if you looked at it for 100 hours. Our students here at George Mason, They just took an image of the Cocoon Nebula, which all total was about 80 hours worth of data. I think it's 80. It's in the tens of hours. And so that is why you can see in those images, you can see things that you can't possibly see with your human eye, is because you have collected far more light than you could with your human eye.
There actually is a question from the chat, and then I'll pass it over to you, Jim. I appreciate you being patient. It was from
I am long-winded.
Darth Mocker. Question for the telescope person. If the telescope is moving at 1,000 miles per hour, how does it focus on a faraway object? I sneeze and my iPhone pic is blurry.
It's all about relative velocity. So yes, we are traveling at 1,000 miles per hour, or what have you, depending on your latitude. The star is but billions of light years away. And so the relative velocities between the star's motion across the sky and our motion through the solar system is nothing in comparison to that distance. And so therefore the object appears effectively, particularly over the time scale of hours or minutes or hours, to essentially be stationary. The only motion that you have to take into account is the fact that it appears to rise in the east and set in the west, which we can do with good mounts.
Yeah, equatorial mount. Yeah.
Mm-hmm.
Yeah, the mounts that track the stars in the sky.
Yeah.
Awesome. Jim.
They counter the rotation of the sky. Yeah.
Absolutely. Jim, go ahead.
Professor Parks, why? I know I've seen some posts on Discord, and you see the NASA, pictures that say image. Why are they image and not described as photos or pictures?
That I don't have a great answer for. For me, I think that becomes just it's a naming artifact, in that a photo is something that is put onto film, whereas an image is something that is computer data. That would be my guess, because that's my distinction. If I were to make a distinction, this would be a photograph, whereas the images that I have on my computer, digital pictures that I have on my computer, I refer to those as images.
What would you say, Professor Parks, is the difference between computer data, which I think you just mentioned, and computer generated?
So computer data, like an image, is data which is collected through an instrument, like a camera. Computer generated would mean that the computer itself came up with the data, that it came basically created the data whole cloth without any external information.
So that image that either we see with or without NASA's help is enhanced or has gone through a computer. Is that correct?
Yeah, it has been processed. Yes.
Okay. Is the computer programmed to give us what the people that program the computer want?
No. The process, the data reduction process. Well, let me back off for a second. When it comes to the science, when it comes to the science, no. Essentially, what's done is there's a process via which these images are reduced, what we call data reduced. So, like I said, there's something called a bias pedestal. You need to subtract off a dark current, a flat field, things of that nature, which I can bore you with technical details if you want. But those things need to be gotten rid of. Then you often will need to stack your data on top of each other, depending on the science that you're doing. In that sense, you have to register them, in the sense that you have to make sure that the images there's going to be some shift, basically, because the telescope isn't perfect. And so you need to get rid of those shifts and basically add a star onto it, the exact same star in another image, and so that you can add up all the sources without any blurring occurring. Now, in terms of pretty pictures have nothing to do with science. The data that we talk about, the things that we talk about that come from these pictures, that comes from essentially those calibrated images. Now, the 3-color images that you see from NASA or NASA, for example, or astrophotographers, private astrophotographers, those images are enhanced, and there is a certain amount of art to them. Are they meant to demonstrate reality? I would say yes, but they are meant to also sort of demonstrate a sort of hyper reality or an enhanced reality. They want the pictures to be really cool looking so that it will spark the imagination and will inspire people in some way. But the science that we extract from that, all of the fact that the universe is 13.7 billion years old, that the Earth is a sphere, I mean, all of that, that is not taken from enhanced pictures. So
I want to divert for just a second before we come back to the subject that we're talking about. You brought up the 13.7 billion, or whatever it is, Big Bang, or how old our supposed universe is. Do you firmly believe, Professor Parks, that a photon, which is light, can travel 13.7 billion years in the vacuum of outer space? From what I understand, Einstein got rid of the ethers and replaced it with empty space, so he could save his relativity. So a photon can travel 13.7 billion years, which is the equivalent, if you believe the speed of light, which is equivalent to 80 sextillion 600 quadrillion miles, with 18 zeros behind the 600, to reach your eye here on Earth. Do you believe that?
yeah, yes, I do.
If you shook your head no to that question and said no, what would be the ramifications of that?
If I didn't believe that the path length, what we call it, of a photon was long enough for the possibility of a photon reaching us, then that would have implications as to the age of the universe. Essentially, at that point, and this is just off the top of my head, but at that point, once that photon interacts with something before it gets to us, then we lose the knowledge of what that photon was prior to that event. That is my understanding. What I'm thinking about is talking about the interior of the sun. So there, but my intuition would state that if the mean free path was not long enough for that photon to reach us from the recombination era, then we would not have a good explanation. We would not have a good match for the background radiation. Would not be a good match to the theory. It would underestimate. I don't know. I hadn't really thought about it.
Your side, your science, some of us would call pseudoscience or nonsense or non-science.
Sure.
Your side says that the photon is massless, massless. It is massless. So if it has no mass and no physicality, how does it travel 13.7 billion years and 80 sextillion 600 quintillion miles to reach your eye? And it's a very serious question. And just because we are told that the photon, which is light, is massless, it has no mass. If it has no mass, how do we know it exists? If it has no mass, it has no physicality. Therefore, it is not a physical object. So that is why many of us on our side that believe in the stationary plane, which I do have on my hat right here, believe that it is complete pseudoscience to think that a massless object without physicality can do that in the vacuum of outer space. What's your opinion of that?
So you make the assertion that if something without mass has no physicality. Science doesn't agree with you on that. Something can have physicality without having mass. That's energy. Energy has no mass, and it produces, and it has electromagnetic effects. It has gravitational effects. So you can have things that have no mass affect other things in different ways. The photon specifically is the carrier particle for electrostatics, or electromagnetism rather. So if you have two electrons that are near each other, the reason why they know that they should repel off each other is because a photon from one got sent off, hit the other one and said, hey, look, there's an electron over here, you need to get the hell out. And so it leaves. So that interaction is caused by communication is caused by photons.
Yeah, I would just add in, love you, Jim, but just to be completely honest with you, this could have been kind of thought out pretty easily because we have the effects of magnetic fields, we have the effects of electricity, and we know that this is part of the electromagnetic spectrum. And what else is light? Regardless of if we want to say it's a particle or a wave or both, we could agree that it's part of the electromagnetic spectrum. I would have a hard time saying that the electricity or the field of a magnet has mass. I wouldn't really know if I could say that.
I think it's interesting. What was I going to say now? I blanked out. Forgive me. You get down to electrons and photons, and of course the electron, you get to the photoelectric effect that Einstein stole in 1905. Will you concede, Professor Parks, that nobody has ever seen a photon or an electron? It's basically a thought experiment.
Have seen a photon? And that is, I don't think it's a thought experiment. I will not concede that. Now, I am very. This is not my field of study, but I do know that there are experiments that have been done where a single photon has been passed through the double slit experiment. Now, how they did that, I don't know, but I do know that that has happened, where someone has experimentally designed a light source that emitted a single photon to see whether or not you would get an interference pattern on the back end, and they did. So somehow a photon has interfered with itself. It's one of the weird things about quantum mechanics, which, again, I will be frankly honest, I don't understand very well. I know that it occurs. In terms of imaging an electron, I don't know. I am not a particle physicist, so I don't know whether or not those things have actually been imaged. I want to say that they have, but I could be misunderstanding what an electron microscope is. Probably misunderstanding what an electron microscope is. But
it fires electrons at the object and then receives them back.
So
just work out the shape.
For
photons, so it's not actually absorbing the electrons; it's actually just using them as a way to bombard.
Yeah.
A single photon, couldn't we all agree that that would just be like the smallest measurable amount of light?
That would be accurate.
Could be a really small wave.
So in the fairy tale of outer space, Professor Parks, a photon travels. Is that correct? Approximately 186,200 miles per second.
3 times 10 to the 8th meters per second. Sure.
Yeah. So if we take away the fairy tale of outer space, which we maybe get to a little bit later, then a photon will not travel. Light will be spontaneous. If from our side, do you understand our side that possibly says that light is spontaneous and doesn't travel?
Sorry, I got distracted by the ridiculously cute puppy.
Sorry.
How old is that dog?
How old? 12 weeks, I think now.
Wow, that's
pretty
cool.
You got a new puppy.
Yeah, she's beautiful.
So that you bring, Jim, what you bring up is a very interesting point, and it's one of the reasons why classical mechanics and general GR are not compatible with each other. Because in an analogous sort of way, what classical mechanics tells us is that the communication of gravity should be instantaneous. That there's no expectation that one mass is going to be attracted to another mass. The amount of time that it takes for that mass to know it should be moving towards the other mass is instantaneously. Whereas GR says, no, that's not possible. Actually, it starts with SR, in that the fastest that something can go is the speed of light. So even gravity is not an instantaneous effect. That the information from gravity does take time to go from one mass to another. In terms of I am a bit confused by when you say that photons are stationary.
Not photons stationary. The speed of the light is spontaneous. In other words, light doesn't travel with a photon at 186,200 miles per hour. I think you own that, or Einstein owned that, which your side has to own now. That he wanted light to travel because it allowed for his outer space thing. He came up with cosmology in February 1917, I believe. He introduced cosmology to the world in February 1917, and obviously cosmology is the study of things out there supposedly, and you have to include some sort of speed of light or light travels in order to maintain that fairy tale. Whereas if we were the center of the universe and perhaps just the universe, just us, whether you get biblical or get a little more scientific, then light is spontaneous, and you don't have light to travel 186,200 miles per hour because we're not that big. If we're just here by ourselves, as Genesis 1, 1 through 31 says, and so I think our side has said that Einstein, other than stealing the perihelion precession of Mercury from Verrier, Verrier, who did it in 1846, stealing the photoelectric effect, stealing M equals MC squared, and stealing the relativity from Poincare, Poincare, and then also marrying his second marriage being to his first cousin, and then writing letters to the first cousin's underage daughter, wanting to have a relationship with her. We are looking at, seriously, Professor Parks, we are looking at our side going, since Eddington and the boys at the Royal Academy in November 6, 1919, gave the blessing for general relativity from 2 slides out of 35 that were taken May 29, 1919, and proclaimed general relativity to the world, and made Einstein the guy who saved the Earth going around the sun, the coordinate system for the Earth going around the sun. We look at Einstein and we go, the man is not what he's portrayed to be, and I have never seen him talk without the help of papers. Now today we call that teleprompter, but back then you never see him talking without the help of a script. And so the world has accepted Einstein as, quote, their boy for 104 years now, but Einstein was nothing but a paper puppet who basically did what he was told to do. And your side has, not necessarily you, but your side has worshipped him for 104 years. And our side goes, that is nuts. Because the guy was I'm not going to use the P word, the guy was actually not a good human being. And we're really, really upset with the scientific community. I believe astronomy, forgive me for saying this, astronomy, astrophysics, and parts of physics, because physics is the study of the universe, is pseudoscience, because it does not exist. And I've told you this before. When you look into the sky, you don't see anything without the help of a computer. So you are pretending, you are imagining, and you are dreaming when you look into the sky. Because according to what we're hearing from you, and my understanding is, you have to have the help of a computer to get that pretty picture that we see. Is that correct?
Wow. Okay, there was a lot there. At the end of that, I will just say flat out no. I guess Ruth left. Now,
Yeah, I've got to go.
Before.
Thanks for coming on, Ruhiv.
Yeah, thanks for coming on.
We're doing
Sorry
a follow-up poll, by the way. Sorry to interrupt. Doing a follow-up poll. People are complaining. Either way, it's like hands are tied no matter what you do, right? Might have to take away the audience voting feature since y'all are so bipolar, but that's okay.
Are people voting me off the island?
No. No one's even attempting to vote you off the island, Rob. You're not going anywhere.
They're voting me off.
I'm just wondering, what do you mean by what's the problem with the voting?
So at first, people are like, "Oh, you gotta kick Brenda off," and then they're like, "Oh, you gotta bring him back," and they're like, "Oh, we don't want to bring him back. Oh, but we want to bring him back." Well, I don't know which way I'll vote. Let's go ahead and it's 54% no again. Yeah, I'm sorry, guys. My hands are tied. Like, what are you going to do?
Professor Parks, you are a very likable individual, no matter what we think of the pseudoscience that you have a PhD in. So I just want you to know, everybody basically likes you on our side. And I want you to know, as a person, I very much appreciate you. I think what you are doing, I think you are lying to the world, whether you know you're doing that or not. I don't think it's good to lie to people. So whether we get into biblical cosmology tonight or save that for another time, I would really like to delve into a lot of things with you, whether we do it tonight or maybe another time. I admire you tremendously because you've done the work and you're a believer in what you're doing. But I think it's a lie. And I've been thinking about this conversation for quite a while, and I appreciate you coming on because I personally think that the globe itself was invented in the pits of hell, and it is now here being promulgated on the world, and we've been lied to for 500 years. Anyway,
from the pits of hell.
Can I chime in about that real quick?
Well, I want to just answer the last part of that one, the previous CCD images or image that you see now. That was not the first way that these images were taken. The first images were taken were photographic plates. I have a picture book over there of galaxies using photographic plates. Those did not require computers at all. And you still see, they are not as good quality as the images that we see today, but you see galaxies, you see nebula. Actually, the data that Hubble took back in 1931, 27, somewhere in there, all of that was photographic plates. There was no computers at all. So all
you need is a concave mirror. That's all you need to see those things. You don't need a computer at all.
Well, you need some kind of recording instrument.
So
not only do you need the telescope, but you need some kind of you need a camera, either digital like today or photographic back in the day.
Yeah.
I will just put that out there that the last two things I will say, so you can get your question in, is we have taken images of the universe and its multitudes without the use of a computer for decades. And the field of cosmology is quite older than Einstein. Einstein is not the father of cosmology. In fact, before Einstein came around, there was the Shapley-Curtis debate, which was trying to determine the size of the universe. Was the universe, were we at the center of the universe? And was the universe, in fact, the size of the Milky Way galaxy or much larger? So the question of the universe itself very much predates Einstein. So, but Apollo, I actually don't know who you are.
I'm Joe. Nice to meet Baller
nice
Joe.
Nice to meet you as well. So,
I think I could point out maybe with a little bit more specificity. I can't say that word. About when Jim's mentioning pseudoscience. There's one that I don't know if you've heard it worded this way before, but if we're going to be, doing science, we make observations, and that there's certain observations that everybody in the world makes that are the same. But then what I see happening, and this is why I call it pseudoscience sometimes, is that we've been taught to infer something that we're not observing that literally opposes our observation. And it's not like the observation is even argued, because it's the example I would give is the ground that we live on. There's 8 billion people here or something.
Roughly.
Every one of us would all agree, I think, that the ground is solid and stable unless there's like an earthquake or a landslide or something like that. The ground appears to be still with all of our senses and perceptions. And we see the sky or the stars rotating above us. So everybody makes this observation of this still solid stationary ground, but we were all taught that it's in motion when we observe it to be at rest. Do you know what I'm saying? And it's like a reference frame thing, I guess. But the point I would make is that our reference frame is right here. I mean, literally our bodies actually are our reference frame, because that's our tools for perceiving reality are all built in our body. And we have measuring tools and things like that outside of our human body. But as far as like observing reality, it seems that we've been taught some pseudoscience. Hopefully that gives an idea of maybe.
Yeah, I think I know where you're coming from. The way I would approach that, though, is when you're talking about, you don't feel the earth move. You don't feel like you're spinning at X amount of miles per hour.
Exactly.
But for me, a more scientific perspective would to actually be able to measure what the acceleration that is on your body, because we recognize that our bodies are very crude devices. I'm not saying you shouldn't trust your senses, but I'm saying that they are not very, very precise at all.
You trust your speedometer, not how fast it looks, right?
Exactly.
Yeah.
Exactly.
Yeah.
Or even how fast it feels.
Yep.
Because, if I'm really not paying attention to this on the steering or the speedometer, or really the environments, I'm just kind of zoning out.
You can't really tell.
Ask me, are you traveling 50 or 40? I wouldn't be able to. I could make a guess, but I wouldn't know with any kind of certainty.
Yep.
So for me, that's where that's where it breaks the pseudoscience, is that scientists use instruments to calculate things and to measure things.
So how could we measure the Earth in motion?
Well, I'm sure you've heard many of the ways that have been used. There has been the infamous laser gyroscope. There has been the Foucault pendulum. If you go from the astronomical perspective, you can do aberration of starlight. You can do trigonometric parallax. You can do redshift of starlight. All of these different things will illustrate the fact that we are in motion. You can also see indirect causes or indirect evidence. Most notably, the Coriolis effect. The fact that we have hurricanes is indicative of the fact that we live on a rotating sphere. If you can explain where hurricanes can come from on a flat stationary disk, and you can give me quantifiable predictions, then I'll pay attention. Then I will definitely look into that. So
may I?
That's where for me the fact that I'm being called a pseudoscientist really kind of rubs me the wrong way, because we quantify things. We look into specific measurements, we make predictions, and we follow through with that.
Before we get too far into the next thing, because actually everybody on this panel except for Joe is really good at monologuing. So I'm going to try to get it to where we can make the points a little bit more concise, because now we're actually starting to dig into the meat of the matter. You mentioned if there was a way to explain it, and mind you, obviously you've heard falsification of a model is independent of reestablishing a new model. There can be problems that falsify what we think of the existing model, and we wouldn't necessarily have to have the mathematical we wouldn't have to necessarily have the dynamic and kinematic equivalent mathematics ready to go in order for yours to be wrong. However, and this is something that, again, I know that you're in Discord a lot, so it would surprise me if you haven't heard this before, but there was a letter between Ernest Mach and Einstein in which Einstein admitted, fully that due to, because basically we're dealing with pseudo forces, right? You can just change them out. You can call it something else. You're saying that you're measuring that all the universe is really far and that we're moving through the universe based on all these inferences. You're inferring that based on the fact that there's red shifting of light. You're inferring that based on all these different observations. However, if most of those are actually explained by like the same thing, right? So if we're dealing with Mach's principle, I mean, that completely explains on a geocentric model. I mean, you can shake your head no, but there's scientific papers that have gone through peer review that, have that as the conclusion that they're equivalent. So I'm interested to know why you would just simply shake your head no, nuh-uh.
I shake my head no, because those papers have been analyzed by other scientists, and the basic underpinnings are wrong. They basically are faulty. I will freely admit I have not looked into this with any sort of depth, but I have looked at the core principle of whatever the relativistic whatever or relativig whatever. And the core principle there is that the center of mass is at the Earth. The center of mass of the universe is at the Earth. There's no justification for that. What they are doing is they are saying, which is true, you can make basically your point of reference anywhere you'd like, because that is the cosmological principle. No place in space is preferential to anywhere else.
But let's just fully acknowledge that worldview was created after we did observations, and all the observations came back that we were the center. Then we had to come up with the idea of why this would be without assigning us a special place in the universe. And this shouldn't even be debatable, right? This is exactly what Hubble was talking about when it said we must avoid the special place in the universe, and it would only be welcomed as like the very last ditch thing to explain an observation. Only then would we accept that as the observation. Until then, if we can come up with some BS to explain it, we will go with that route.